Namaste Vidya, I JVWU Muskan Kumari from the Department of Science and Technology, and I am working here as an assistant professor in JVWU University and the Faculty of Education and Technology. So today in this session I will discuss with you the basic classes of the IP addresses, and just before this session I have already discussed with you the IP addressing and the network layer, isn't it? So this session will very easily to understand it to all of you. So, to understand this session, I just want to clear some things regarding this. Uh, so, I am just going to share some files which will help you for the better understanding about the classes of RPLS. Okay? So, here is the so here is the basic classes of IP address. Okay. So you will know that the IP address is just about the 32 bits in which there are 4 octants. Each octant contains the 16 bit, clear? 8 bits, sorry. Each octant contains the 8 bit and there are the 4 octants which contain the total number of 32 bits. So 32 bit IP addresses are divided into the 5 classes: class A, class B, class C, class C, and class D or class E. Okay, each classes has a valid range of IP address. Class D and E are reserved for the multicast and experimental purposes respectively. The order of bits in the first octave determines the class of the order of first octave determines you the classes of an IP address. IPv4 address is divided into the network ID and host ID. This is well known to you. The class of IP address is used to determine the bits which is used for the network ID and the host ID, and the number of total networks and hosts which is possible in this particular classes. So the internet service provider also our network administrator assigns the IP address to each device that is connected to the network. As you can see in this diagram, that there are byte 1, byte 2, 3, and 4. 1 byte contains the 8 bit. For the class A, how we can identify that this IP address is in for the class A? Whenever the byte first, we are always checking the only the byte first, that network ID and rest of the host ID. Class B, 16 bit is the network ID and 16 bit is host ID. Class C, class C, what will be the 24 bits is the 24 bit will be the network ID and 8 bit will be the host ID, and class D all are the reserved for the multicast address and class E is reserved for the address. So if you talk about the class A, IP addressing belongs to the class A are assigned to the network and contains a large number of the host address also. Clear, because in this we are using only 8 bit for the network host and network ID and rest of 24 is for the host ID. Clear? So the network ID is 8 bit and host ID is 24 with the higher order bit of first or 10 in class A is always set to 0. The remaining 7 bits first of 10 are used to determine the network ID. The 24 bit of host ID are used to determine the host in any network. The default subnet mask for the class A is 255.x.x.x. Okay, so therefore class A has total number of what? 2 to the power 7 minus 2 equals to 128 minus 2, so that's will be calculated as 126 as the network ID. Here, two address is subtracted because 0.0.0.0 and 127.xy x.y.z are a special address. So 2 to the power 24 minus 2 equals to this one is the host ID. So if you have given any IP address and you have to say that calculate the network ID and host ID, then you will easily calculate that ones, okay, for any class of IP address. So The IP address belongs to class A, ranges from 1.x.x.x to 126.x.x.x. So here is 0 is used for reserve for identifying the class A, and 7 in the network ID. Total is 8 bit, 1 bit 0 is reserved at the starting bit for the network ID, and the 7 is the network, and rest of the 24 is the host ID. Now, if we talk about the class B, so IP address which belongs to class B are assigned to the network that range from the medium size to the large size of the networks. The network ID is 16 bit and host ID is also 16 bit. The higher order bits of first octet of IP address of class B are always set to the 10. The remaining 14 bits are used to determine the network ID. The 16 bit of host ID is used to determine the host of the network, and the default subnet mask for class B is 255.255.x.x. Okay, and so if you calculate the total host ID and network ID, then you will easily calculate 2 to the power 14. It means here two bits are reserved in the network ID. One is 1 and 0. Okay, so there left is 20, 14. So 2 to the power 14 equals to this one is the network address, and if you calculating the host address, 2 to the power 16 into host address. Okay, and the range will be goes from the 128.0.x.x to 191.255.x.x. Okay, so if we talk about the class C, the IP address belongs to class C are assigned to the small size networks. The network ID is 24 bit blocks, the host ID is 6 bit 8 bit blocks. The higher order bits of the first octet IP address of class C are always set to the 110 here. So using the 24 bit 3 bits are reserved, and 21 bits will be left as a network ID, and host ID is 8 bits. So if you have to calculate the network address and host address, then you will easily calculate here 2 to the power 21 equals to this, that one is network address, and host address is 2 to the power 8. Yeah. So if we talk for the class D, then we will directly say that reserved for the multicasting. The higher order bits of the first octet of IP address belongs to the class D are always set to 1110. The remaining bits are addressed to the interested host recognized, and the subnet mask of the IP addresses ranges from 224.0.0.0 to 239.255.255.255. Okay, so you can see here 111 and 0. This is for the host ID, and the rest of the this is the network ID, and the rest of the host ID. If you talk about the class C, the IP address belongs to class C are also reserved for the experimental and research processing. IP address of class E is also ranges from 240.0.0.0 to 255.255.255.254, and so the starting of the bit is always set like 1111. Okay, 4 ones. What is the role of the assigning the host ID, and what will be the role of assigning the network ID? Here are some specification rules. Host ID is basically used to identify the host within a network. The host ID is assigned with within a network. Host ID will be unique to that network, and host ID in which bits are set to be 0 cannot assign, because this host ID is represented in the network ID and the IP address. Host ID is always a bit are set to 1 cannot be assigned, because this host ID is reserved for broadcast service presenting. If we talk about the network ID, so hosts are located on the same physical networks and are identified by the network ID, and all hosts are which is on the same physical network assigned the same network ID. Also, the network ID is assigned on the following rules. The network ID start with the 127 and belongs to 157 belongs to class A address and is reserved for internal lookup function. All beta networks are set to 1 for all the IP broadcasting. So here are some which is showing the address ranges of, and suppose class A as address ranges 1.0.0.1 to 126.255.255.254. Suppose 16 million hosts on each of 127 networks. Class B 128.1.0.0 supports 65, 65, 65,000 ports on each 16,000 networks. Okay, so this is similar as the class C and class D and class E, and every IP address breakdown. IP address is breaking into the four octets that is which I have already discussed with you. Each octet contains the eight 2 byte that is of 8 byte 8 bits clear. So this is the example of that ones also. And static and dynamic IP address is what IP address which is assigned for the different way. They may be dynamically assigned, so they can change automatically or statically assigned. And most of the network use dynamic elevation. Your router use DHCP to temporarily assign and leaves the IP address to your device. So after some time, this release it requires that routers use your older address are assigned to the new depending on the routers. Okay, so this is the basic of the advance. How data is saved to the IP address on the network component. Data illustrates how your home network might be obtain an IP address and send the data to the IP address on the network. So this is the example which is so to you that your computer connects to the router of the IP using and asks for the local IP address. So the router responds given to the computer. So the local IP address is here somewhere, and your request or the router request of an IP to connect the internet ISP assigns your WAN address to this ones, and when on the address while on the network you request access to the computer web server by including the URL using TLS. That address is translated to the IP address also, and TCP IP protocols in packets travels over the multiple routers and computers until it reaches the address. And your TCP/IP packets reaches to its destination and communications with the other computers. Also, it responds and repeats the error states to get the data back to your computer. So this is all about the stations of your IP address on our classes. And if you have any problem regarding this station, then please let me know about your informations and which I will discuss with you. And please read this station very carefully once again, and also refer the multiple standard books and all online access of websites. And many more questions will arise through this one that write the IP addresses with their class names to find this on this, isn't it? So please be prepared for this all the things. Okay, thank you.